All right. Hello, everyone. It looks like you're all coming in. Just bear with us for 1 minute, and we'll wait for everyone to get in here before we kick off. Thank you for joining us. Excited to have you here. It looks like people are still coming in. Awesome. We have over 100 people joining us live today. Feel free to drop in the chat. Let us know where you're from. We're going to keep going. Look at that. 111 people live right now. Hi. How are you today? Thank you for joining us. We will have some live question and answers at the end. So please save your questions for the end. But it looks like we have everyone in. We are going to go ahead and get started. Thank you so much for joining us. This is the Autodesk Tinkercad 3D Design Sneak Peek webinar. We're here to talk about the newest forthcoming certification from Autodesk that is focused on Tinkercad. And we have a very special guest with us today, Guillermo Melantoni. He is the principal product manager at Autodesk and the lead for the Tinkercad product. He is going to kick us off today, and then we're going to have a short session afterward by Sabrina Beck, the product manager at Certiport that's over the Autodesk program on our side. Guillermo, you want to go ahead and get us started?
Yeah, absolutely. And thank you everybody for joining, and thanks Certiport for having us too. I will get started. So yeah, my name is Guillermo Melantoni. I work at Autodesk. I'm product manager at Autodesk, and since 2013, I've been kind of owning Tinkercad, let's say. And what I want to do now is do a bit of an introduction about what is Tinkercad, and maybe some of you will say, yeah, I that's why I'm here. I know what it is. But there's a lot on Tinkercad too that I would like to make sure that everybody has a good understanding of the big picture of what we're trying to do with the product, and then we can start kind of getting more into the certification itself with Sabrina after maybe 10-15 minutes of you hear me talking. Normally when I'm presenting, I will not be looking at chat or everything because I'm working live. So if there's any questions, again, we can take them all at the very end. So you tell me how to do it. But right now I'm going to share my screen. And once I do, please confirm that you can see my screen. You do? Yes, good.
Yes, we can see it.
Perfect. So yeah, I mean, Tinkercad is one of the many Autodesk products, but it's also a very special one. It's the one that has been made for a very special audience within Autodesk, which is beginners, right? Beginners, students. I think I would like to. We believe, and we believe that we're building a product for kids and for anybody that starts beginning with CAD, but mostly thinking about kids and K-12 in particular. And just not to brag, but to show kind of a little bit of the scale of Tinkercad. I think it's important to sometimes kind of have a sense of this. We are very close to our 100 million registered users. That's something that not many products out there can say. And that gives us around over 5 million monthly active users. So people that are opening and working on Tinkercad in a month. Another over 500,000 people coming in every day to work on Tinkercad, and actually around 100,000 new users on peak days. Let's say around back to school, on the busy days of back to school, we get up to 100,000 new users. Right? Just think about your town, think about the biggest stadium that you have there, and probably multiply by whatever it takes to get to 100,000. That's all the many places we fill up with every day on Tinkercad with new users. Teachers, first of all, thanks for using Tinkercad. We got over 3 million of them. and 370,000 of those are monthly active teachers. So there's really good numbers that show the scale of Tinkercad. Who do we build Tinkercad for? First of all, I mean, we're part of Autodesk, that's clear. And Tinkercad is basically, again, being built to introduce students into STEM, right? Into STEM related disciplines. So Tinkercad, you can kids start with Tinkercad very young. We have classes on kindergarten on Tinkercad, but I would say where we start seeing the scale and the real numbers on Tinkercad go pretty much from third or fourth grade in elementary school into sort of halfway in high schools. Yes, we do still have uh, students in college using Tinkercad. We also have professionals using Tinkercad, but our sweet spot, I would say, goes towards between middle of elementary school and middle of high school, right? After that, if you're in a STEM career, we expect you to want to start be using Revit or Fusion or 3 Studio Max or Maya or AutoCAD, inventors, things like that, right? Because that means that you're already on a path into a professional activity. And at that point, Tinkercad is not the right thing, right? It's not meant for that. So what we have is this amazing ecosystem that in which sometimes most people know us mostly for the 3D modeling and the 3D printing out of the 3D model, right? That's what kind of most people just think about Tinkercad. And yeah, I mean, many people, if not everybody, kind of starts there. And always, normally I always find that the first thing that people do is the name tag, which is awesome, right? I mean, a name tag has everything. Everything that's good about a 3D model is it's a name tag, right? It's a flat object with a name on top, so very easy to build. You can make it much fancier by maybe rounding one side and putting a hole because then you want to hang it on a backpack. And all of a sudden it's portable, it's relatable, it has your name. You can show it at home. You can brag it walking around. The printers in general will not fail with something so simple, and also will be fast because it's flat, right? So it's amazing. But eventually you want to do more, right? And you want to do more. And for example, in this case, you might want to start doing objects with, yes, that you want to 3D print in plastic, but maybe those objects have lights or sensors, and you can start using all the electronics pieces of Tinkercad. And eventually, this is sort of kind of the apex of what I would say I would like to do in something like Tinkercad, which is a full kind of autonomous line following robot that is designed on Tinkercad circuits, that is also designed on the 3D side of Tinkercad and all put together to actually work, right? So that from the basic name tag into something like this, all of this we can cover, and we can walk you all through everything we can do. And eventually also, if you may want to think, if you're in a district or in a school in which you are a certain grade, but then there are people after that, to actually help kids kind of carry the same solution into their more like sophisticated workflows, and then into what happens next on the lives, either that be something like Fusion or Inventor again, or something in architecture like Revit. That's all great. So in a nutshell, we do have this ecosystem, these 3 workspaces on Tinkercad, which I'm going to show very fast right now, which is 3D design, making a simulation, electronic design and simulation, and then 3D design via visual programming, right? Using something very close to Scratch or Blockly, right? Kind of the Google Blocks or Scratch blocks. And with that said, I'm going to switch into live, because we all prefer live demos, right? Everything's going well so far. Janet, Sabrina, just thumbs up. Great. So I'm going to start with again with the most basic thing. This is Tinkercad, right? Empty canvas, just started. A lot of different objects on the side. I can easily just drag and drop a box. I can see it from the top and realize that basically this box, if I see it from the top, it looks like a rectangle that I just added to a Google presentation or to a PowerPoint. And I kind of already know, and everybody knows already, that they can drag these things for a non-uniform scale, or if they press shift, they have a uniform scale. So my point here is that Tinkercad is very relatable, and you probably already know Tinkercad by just doing some simple things like those, right? And we added a lot of things on Tinkercad that make it much more interesting. For example, cruising allows any students to not only put something, but also understand that it goes on top of something or on the side of something, because the younger kids don't understand depth that well. So if somebody puts something here, they might think it's on top of the box, but it's actually on the back of the box, right? Just because of perspective. So if now I have something like this, or maybe I'll just duplicate this one and I'll create a second one. And now I add, or maybe I'll add something like this here. Not only I'm designing really fast, but also one other thing that I can do in Tinkercad now is also simulate it. So if I go to simulation, all of a sudden, and this may be something that many of you have not seen, now you can realize, okay, this is not working well, right? So at that point, this is a great moment for a teacher to start asking, okay, how would we make this not fall? And maybe one of the answers would be move this support a little to the right. Why? Because then the distance between the free spot and the support is smaller, so then the work is smaller. So then probably this thing is going to work well, right? And there's a lot of really good learnings on things like this. And of course, just to make it fun, then we can start throwing things at stuff, right? Because again, we in order to work in software for kids, you have to also think like a kid sometimes. So we sort of like to think that we do that. And another scenario here, for example, you can go really complex, right? I mean, I'm not expecting many people to do something like this, but this is a couple thousand parts bulldozer built completely natively in Tinkercad by somebody that had a lot of time, right? But it's amazing how complex can things get if in Tinkercad, right? So if somebody says, "Oh, Tinkercad is just like a toy," well, you can use it for very simple things, but it can take you pretty far, right? And if thinking again about some of the animations I was showing you, the simulations I was showing you, if you look at this one, for example, this is a kind of a remote control car, and if I play this one, because it has already a connector, I can also make it run, right? So here I'm using AS and DW because the key is ASDW because this is how I made it. I did the programming. And how do I do something like this? Right? It sounds like almost sorcery on Tinkercad. The way I did it is if I reset, Tinkercad now has the option to create connectors that not only connect things to each other, to different elements, but also in this case, I can define this is a motor, this is the torque, the speed, right? Again, Tinkercad has grown into a very, very powerful product. Same I can say with this kind of simple Newton cradle, right? So you expect this to happen. These lines here, which are called tracers, will allow you to actually check different things, like for example, velocity or acceleration, right? What happens, there's a lot of acceleration when the red ball is coming down, right? And then the other one, you can see what happens on the other one, but also we can see, for example, total energy. So we can see how the energy is high on the first ball, and then it goes into the next one, and there's some diffusion of energy until the thing goes into a rest at some points, right? So this is all great things that you will be able to do eventually on Tinkercad. Just one more thing, two more things, and then I'll start kind of wrapping up. This is our circuits environment. In this particular case, I just wanted to simulate three lights, like it was a traffic light. Since there's an Arduino, there might be a way to code it, and we coded using Scratch blocks, right? Which in our case, we call it code blocks. But we work very close to the Scratch team, right? So we made sure also that if somebody knows Scratch, they kind of know this already, or at least the foundations of this. So in this case, what I'm trying to set this to turn on the red light, wait a second, turn on the yellow light, and the same on the green light. And in this particular case, I also added resistors on the red and the yellow light and nothing on the green light. So what happens if I start the simulation? The first one will turn on, then the second one will turn on, and the green will explode, right? And while probably exploding LEDs is very fun, it's also very expensive at some point. So the good thing is that you can actually try things on Tinkercad and realize, oh, I didn't put a resistor because there's a lot of voltage coming from here to be able to be handled by the LED, and I need a resistance because, again, as we all know probably from physics, the current equals voltage divided by resistance. So the higher the resistance, then the lower the current that can burn or not burn this object, right? So again, imagine all the things you can do on electronics. And on the coding side, and this is a very simple thing too, when you build on Tinkercad in the normal kind of well-known 3D environment, anything you build, I mean, you can build whatever you want, but if you already did it and you want to make a change that's very foundational, it's very hard to make that change without doing everything again. So in this case, what I'm going to do now is grab a cylinder, make it really, really thin and tall, and then rotate it and repeat the rotation a certain amount of times, which is based on a variable that I set up here as 4, right? So what happens when I run this? This is what I get. So I do 1 and then 4 times repeated. So it's 5 objects. But I can also say now, okay, I want it 15 times. So at this point, the rotation angle will be 360 divided by facets plus 16. So in this case, so we don't repeat any objects, and this is what we get, right? So what this is almost like the foundation or the beginning for what you will be calling parametric design if you go into Fusion or to Inventor, for example, or into Revit, right? In which the designs are driven by variables that you can change on the fly, right? So all of this is Tinkercad. Now, when we think about Tinkercad, in the sense of what we wanted to do here with Certiport, we wanted to start on the place that everybody uses, right? On the 3D environments, the 3D environment that everybody knows and loves, right? And it's the most used to. And this is now what Sabrina is probably gonna do a much better job than me, just talking about how this certification works and what it includes. And I really want again to, first of all, thanks Certiport for the opportunity of having a certification on Tinkercad. I know that this has been asked by many teachers, many schools for many years. And now that we're here, I'm so excited to see what we can all do together.
Awesome. Thank you, Guillermo. Hey, we have two quick questions. I just want to get them addressed. It does say, should every 3D design be tested in the Sims lab?
No,
Do you have an opinion on that?
no. I mean, doesn't need to. I would say, if, for example, I've seen many teachers or many people in general that use the SimLab, for example, to see if the object is going to stand. Let's say that you're building like a little model of a duck, let's say, right? And then you just use gravity alone. Does the thing fall? If it falls in SimLab, it's going to fall in reality, right? So before you spend 5 hours 3D printing a duck, right? That is gonna not stand. Then you'd better do it, right? But it's not a something that you have to do. You don't have to do anything, right? On any of these things. I mean, I think that SimLab is a very fun environment to understand how your models react in the real life, right? And that's pretty cool already, right? So you can find many different examples of things you might want to do with that, just to teach physics, to learn some math concepts, to talk about gravity, or to just make a model and see how it behaves, or turn on the shake table and simulate an earthquake on your building and see what happens, right? There's a lot that you can do.
That's cool. And is that SimLab available with the free version that you guys offer in education?
Well, Tinkercad is free for everybody anywhere.
Okay.
And so everything is available on Tinkercad for everybody. So whoever you are, you're in a school, you're a professional, anybody can use Tinkercad at any point, right? It's as you many of you might know, all the Autodesk offerings are free for education. In the particular case of Tinkercad, since again it's aimed mostly to beginners, right? It's free for everybody.
Awesome. Thank you. Um, So there's a couple more questions. We're going to hurry and answer these last two questions, and then we're going to hand it off to Sabrina and let her do her part of the presentation. And then you guys are going to be welcome to ask questions again at the end. But just for these last two questions, it says, can I save a .dxf file for CNC plasma cutting?
Uh, it's funny that you say it. Uh, no, I would say not yet. But if you see down the window, I'm in Birmingham. Birmingham is the place where we have all the office of Autodesk that does all the CNC stuff and all have all the fancy cutters and everything. So maybe eventually we might have some surprises at some point of the year, but today we don't. If you want to do something with CNC, what I would suggest is we have a workflow that sends from Tinkercad to Fusion, right? Fusion is our professional solution for design and manufacturing. We're part of the same group. Actually, I'm also product manager for Fusion, so I work on both sides, but I'm the head for Tinkercad. And you can send a model from Tinkercad to Fusion, and then in Fusion you can start all the processes for plasma cutting, for milling, for turning, or for 3D printing on different materials, on everything, and do a lot of simulations for any of those workflows there. But the short answer for you today is no DSF export for Tinkercad, but you can export an SVG today. And if you export an SVG, you can already probably do a lot with that. The good thing about sending to Fusion is that when we send to Fusion and you're working with basic primitives, with basic shapes on Tinkercad, if there's something that's a curve in Tinkercad, actually on a Tinkercad, it's faceted, right? It's made of small, kind of tiny, like straight lines, right? On Fusion, that gets converted into a real curve. So if you then start your plasma cutting from Fusion and you had a curve, in Fusion, it's going to be a perfect curve. So kind of long answer, hopefully why it was not too confusing, but yeah, I'm
A
so
little
excited
bit
about
for
the
me,
things
but
we're
I'm sure
doing.
he understood. Let's answer this last question. Um, Matthew is asking, is the mass of the objects in the sim lab always the same, or is it changeable based on object color or something?
Oh, okay. I need to share my screen for a second again. So I'm excited about all the questions. Feel sorry about Sabrina. Just hang on for a
No
second.
worries.
We'll get
No
there.
worries. This is totally
So
fine.
for example, let's go back to this one here, right? So I can select a material, and here I have plastic, concrete, ice, polystyrene, rubber. I mean, a lot of things, right? So if I do concrete, here my volume is still always going to be the same, of course, right? Because I don't change the size of the object, but the mass is going to be 24.74 kilograms, whereas I use polystyrene, it's 860 grams, and so on, right? So that's great question, by the way. We also report, again, on the materials, we also report friction, restitution, which is kind of the bounciness, how much something can bounce there, and the density. So for example, if you have a ramp and you have an object on top of the ramp that's going down, you might design things with more or less friction to change the speed of how the object is going down, for example. So if you're doing some sort of Rube Goldberg kind of uh, scenario, right? Something like that's a very normal exercise on maybe from 8th, 9th grade, something like that, in some STEM courses. You could pretty much build it all on Tinkercad and simulate it and see how it works.
Pretty cool. Awesome. All right. Hey, thank you, Guillermo. Appreciate it. We're going to hand it over to Sabrina, and she's going to give us the presentation for the Certiport side of this. Sabrina, why don't you go ahead?
Awesome. Thank you. Let me go ahead and share and start my slideshow. I hope everyone can see my screen. There we go. Like Kenneth mentioned, my name is Sabrina Beck. I am the product manager for the Autodesk Certified User Certification Portfolio at Certiport. We have been working for quite some time with our Autodesk counterparts on bringing this new certification to fruition. At first, I just wanted to kind of overview. At first, we asked ourselves several questions. I mean, we're always asking, how can we better help educators, we in particular wanted to be able to provide additional tools that would help educators better connect students to the design and make career pathways sooner through certification. And we also want to make sure that educators feel prepared and supported to teach CAD. So looking at the gap that we have, these are just some interesting statistics to talk about with regards to STEM education, computer science. That 88% of teachers agree that computer science is critical to ensuring future success in the workplace. It's increasing that all new jobs in STEM require computer skills and abilities. And there is a good amount of teachers that don't think that students are taught enough computer science. And I hear this all the time with teachers that I speak to. They feel underqualified when it comes to preparing students for digital futures. So with that in mind, we wanted to address the roadblocks that educators have. They're often being taught to teach subjects without being experts. And how can we break this down into easy to teach concepts that will keep students engaged? How can we help them collaborate? Collaboration is such a big part of career success. How can we get them to collaborate now with students? And most importantly, how can we validate and recognize students' efforts so that they feel motivated to continue on the design and make career pathway to gain employment? So with regards to our Autodesk certification pathway, we identified an opportunity with this certification to bring students into the design and make pathway through certification earlier than the Autodesk certified user portfolio. So here you can see the full pathway that Autodesk offers. I know as educators, we are very familiar with the Autodesk certified user program, but it is a foundational level of certification that Autodesk offers. It goes all the way from the certified user all the way to certified experts, where industry experts who are considered leaders in their field and subject matter experts live with their certification. So adding the certified level at the very beginning will help motivate students to continue in the design and make career pathway. And I didn't know if you are aware, but Autodesk does offer opportunities for professional development and support for educators. So the Autodesk Tinkercad 3D design certification focuses on the 3D editor, the 3D design aspect of the Tinkercad program. It is the entry to our design and make certifications. It really focuses on the 3D design and modeling skills. And not only that, but also really focuses on those digital literacy skills as well, with understanding how to collaborate with others and go through the design process. It also leads into more advanced programs like Guillermo mentioned. It directly ties into Fusion, but I've also talked with educators who are already using this as a stepping stone into Revit, especially with creating dioramas and understanding the interior design that way, and also Inventor. Our certification will be live and available at the end of this month, with that, which we're super excited about. The prerequisites for the certification, as I mentioned before, basic computer skills, digital literacy was a big topic with our subject matter experts that helped us create this exam. Understanding basic geometry, also naming conventions for files, how to create a new one. They felt that this was a really important thing because they had students all the time that would work in their file and on their program, but they wouldn't save it, and then they would go back to grab it and it wasn't there. It wasn't where they expected it to be. So being able to understand how to create and save a file appropriately is super important. And then also understanding Creative Commons and copyright um, laws in their respective regions. So as they're working on files and also working with other creators' files, they understand appropriate attribution and whether or not they're allowed to use those those designs in those files to begin with. The learning objectives, these are just a super high level of the learning objectives that we have. Basic computer skills, understanding the basic tools and navigation. Wait a second. Okay. I'm not sure what happened to my slide, but I can speak to that. Basically understanding understanding like the basic tools within Tinkercad, understanding the basic design process, understanding how to collaborate with each other, understanding how to find solutions to specific problems, also understanding and compound operations within the software. It's pretty awesome, the things that we focus on. We know that Tinkercad has a lot of functionality, especially with the other, like with the code blocks and with the other areas that Guillermo showed. We opted to start first with focusing on 3D design, specifically with additive manufacturing and helping students get ready to create like physical products that will help solve problems. So with this, with our full offering, we have a blueprint to success that we follow. We always make sure that we have an easy to teach curriculum. As Guillermo mentioned, Autodesk has free resources already for teachers that are pretty amazing. They're really in-depth, they're super fun. They really focus on providing teachers with the tools that they need to help students learn the skills that they need for this certification. That's also, if anybody has any questions with getting things approved within their through their administration, the curriculum and everything with associated to Tinkercad already aligns to standards with ISTE and CSTA. We also are working with some of our learning partners to provide additional materials as well that can be used in the classroom. We also will have a practice test, a Cert practice test that will help students prepare for the certification and see where they're at in relation to their knowledge, and help them prepare so that they have a better success of passing the certification when they're ready to take that. And then the certification will be available at the end of this month. And that is my last slide. So I think.
Yeah, thank you so much, Sabrina. That was really informative. We're going to open it back up to questions. If anyone has a question now, you feel free to drop them in the Q&A section. I'm going to touch on a couple of them. Let me see. Yes, we will send a copy of this webinar out to everyone after the fact. Sabrina, they're asking if there is a recertification needed after a year or so from earning the original Tinkercad certification. Will that happen?
So as with all of the Certiport portfolio, I know we just barely announced this yesterday. There will be a recertification that anybody who has a certification after 5 years. In order to recertify, you just have to take the exam again. So that will be part of it. Our hope is that students will want to continue their certification journey with the Autodesk Certified User Portfolio, go into Fusion, and the other certifications that we offer as well.
Okay, thank you. I'll answer this other one. They're asking if it's going to be added to the Florida Cape list. We are going to do the application, but there is no guarantee. That's ultimately going to be up to the Florida Department of Education. But we will try to apply for the Cape list. Yes, we can share the presentation afterward. If I could ask the presenters to please email me their slides, we will make them available along with the recording, which you should get a follow-up email for in the next day or two as we put all of that together. How long would the certification take for students is one of the questions.
Okay, so initially, so I do want to answer, I see a couple of questions also coming through the chat that tie into this one. So our primary audience for this is definitely middle school. But when you look at a level, because we also understand that high schoolers use this, and there are also enthusiasts that use Tinkercad as well. And so we really want to focus on the fact that this is beginning entry level into 3D design and make. With that, yeah, I'm just reading through the question.
Oh, you're fine. I'll
Yeah,
I'll mitigate the questions.
okay,
They are asking if the practice test will be
yeah,
available before June 30th or on June
yeah.
30th, is my
Yeah,
understanding.
so the practice test will be available later on this summer. We're expecting it to be done at the end of middle to end of July, and so that will be available. It technically, as far as like learning with the requirements, our SMEs felt that um, at least 20 hours of instruction would be needed, like in-person instruction would be needed to before they sat with the certification, in addition to additional hours outside of the classroom working within the software. This is primarily due to the fact that this is a middle school certification, and we assumed that this would be integrated into a different, like in another class, a supplemental class. That said, I do know that CAPE requires 150 hours of um, of of education and instruction in order to be able to get on the CAPE list. And with the additional curriculum that we have, it will fit that need.
Okay, perfect. Um, so we have one person asking how to access the certification test. That'll be available through Certiport. Contact your local Certiport rep or go to certiport.com and you can request to contact a representative and you can figure out all about that. Um, let's see, there's a couple more. Can How many tests is it total and how many questions?
All right, so this is what we term a selected response exam. It's just like our fusion exam, set up with multiple different types of question types. It does not require the software to run. It is a 50-minute exam with approximately 30 questions.
Okay, thank you. Can teachers
And
have access to the Tinkercad lessons to introduce within the lessons? I'm not quite sure what you mean there, Dr. Tai. Is there a training for teachers to get certifications prior to the student introduction? I think that is the rephrasing of the question. Um,
there is a lot. I encourage you to go to the Tinkercad website and check out all of the curriculum and lesson resources and tools they have. It's pretty in depth. There's also a Facebook group, Tinkercad for Education, that is very active, and there's a lot of teachers that are there to support each other. We are working with some of our learning partners to create the lesson plans and the objectives like we have with our other portfolio and our other curriculum we offer through LearnKey and Brain Buffet, which do have what you're asking for. So those will be coming. And I do want to touch on Ralph Terzoni's comment. We are not overlooking high school at all. We very, very well know that there are a lot of students that come in that are interested and have no CAD experience, whatever, and this is being used. Tinkercad's already being used to introduce that to them, and that's why I mentioned it earlier that we want to really focus on skill as well. That this is a great place to start with, no matter your age or ability.
I'm sorry, I would also say even community college. I mean, there's a lot of
Yeah.
scenarios in which Tinkercad is getting used to level up people because you never know what's the experience they're coming with. So yeah, it depends. I mean, as teachers, you know who you're working with and what you have there, and you'll figure it out if you want to sound Tinkercad or you think there's already a level of there's enough background on the students to maybe just jump directly into something like Fusion, which again it all depends on where do you see your students. But I'd say Tinkercad for a beginner is just a fantastic place with zero frustration, right? It's simple. It gets you to the good results. It gets your feet wet on the world of designing in 3D, and then kind of the imagination is the limit, right? So, and then of course there are much better tools to take that further.
Yeah,
All from
100%
Autodesk.
agree.
And there's another question. It says looking to integrate with high school robotics and integrate with 3D printing of custom parts. So would Tinkercad be appropriate level for this? I can say that one affirmatively, yes, absolutely. Robotics is a major emphasis for Tinkercad, and it is already being used pretty widely in education in exactly that spot. Um, there's a couple questions around cost. I don't know that we have all of that fleshed out as we're coming to market. I'll leave that to you, Sabrina. Do you have an answer as far as how
Um,
much will the exam cost?
so it will be in alignment with our other certifications. There's a bunch of different factors that play into cost, but it is definitely not free. If you have questions about what it would cost to implement into your specific program, feel free to reach out to your Certiport representative, and we can get you that information.
Awesome. Will the certification and Tinkercad make challenges or innovation contests this year? Is that something Tinkercad does, Guillermo? Are there innovation challenges? She says I teach seventh and eighth grade with this. She's curious what kind of contests there might be out there.
We don't call them contests. We do challenges, and we always do challenges, and we'll keep doing challenges because it's a great way again of keeping people motivated with some healthy sort of competition too. Yeah, and we have some really nice ones. I mean, if you use Tinkercad, you will normally notice if you go to your dashboard as a teacher, you sometimes you'll get some notifications for some challenges. So we have some really nice ones coming in. We had a really good one, but kind of making it real, kind of make it livable. There's a lot of things we've done so far, and yes, absolutely, we firmly believe that we need to put some problems to solve in front of people, and we're always amazed and humbled by the imagination and the creativity of everybody.
Okay. We did answer there are Tinkercad solution files available for teachers. You can find these on the Tinkercad website or through, are they available on the Autodesk Education website as well, or should they go to Tinkercad if they're looking for resources for the classroom?
For the classroom, meaning like examples?
Yeah, yes.
Yeah. I mean, there's definitely on the Tinkercad site, under resources, you will find I mean, from tutorials to lesson plans, and lesson plans by subject and by age too, and also we have a full set of projects at the very top of the navigation, and those projects are also divided by subject and by age, and most of those have been made by people like you, by teachers, right? So submitted by teachers, which I think gives much more credibility, right? So it's things that other teachers have been super successful with that they want to share with everybody else. So yeah, just take a look at those things. I would say if you're new to Tinkercad, start with tutorials, which is the way just to learn how to use the product, right? Lesson plans are more structured, a little longer, little projects that you can do that are very guided, and then you can go to projects which are much bigger, right? So you just be you, right? Just depending on where you are in your path, you'll figure out exactly what you need. But I think that we're offering already a very nice set of examples on there.
Okay, well, thank you for all the questions, everyone. This is there's a lot of them. We're gonna hurry and try to get through these last few, and then we're gonna wrap up because we do have other places that we need to be today. Eileen asks, does Tinkercad work with Glowforge? I don't know the answer to that.
I mean, Tinkercad basically creates files, like exports files that can go into whatever you want, right? So I mean, by Glowforge, I am assuming you're trying to laser cut. If that's the case, normally the software from those from laser cutters, from even from a Cricut or a Silhouette, or anything that cuts, right? Normally accepts an SVG as an input. So anything that accepts an SVG can be done Tinkercad, and if not, again, you can drop it into Fusion, and from Fusion you have a much wider set of tools to control what you're doing, and also a much wider set of printers or cutters or whatever you're doing, right? Available. So yeah, answer is convoluted answer, yes.
Sabrina, Jeremy is asking, why is it not classified as a certified user exam? Do you?
The reason why we didn't classify it as a certified user exam is because we are only focusing on one aspect of the software at this time, specifically with 3D printing, which gives us an opportunity to add more later. But we also wanted to provide an opportunity for younger students to enter into the design and make certification pathway. The ACU, I mentioned before, is the foundational level for the Autodesk certified or the Autodesk certification portfolio. It does tend to be considered a more advanced certification for high schoolers. So with that in mind, we really saw an opportunity to provide more of a basic beginner entry-level certification into that portfolio. And so at this time, it's that certification. Autodesk certified is what it's being called right now.
So is this intended for teachers to get certified or students or both? Nick is asking.
Yeah, I think both. Absolutely. Anybody who wants to get certified in Tinkercad can. I know that a lot of hobbyists and enthusiasts use this. And like Guillermo mentioned before, you have people that are trying to upskill and reskill that need somewhere to start. And this is a great way to show that they are transitioning to that career pathway.
Two more questions we're going to answer. Joan asks, when will teacher training be available? Is there a plan to create specific teacher training for this beyond just what is going to be available with the various curriculums that we have coming?
Yeah, so we are working with a couple of new learning partners that currently have instructor training. So that should be available later on this summer. But it is available independently now. So it is already on market. And I do know that there are a lot of tools on Tinkercad's website for that specifically.
Awesome. And this last question, maybe this is for a little bit for both of you. If someone comes to me in an AutoCAD or Inventor course saying they know Tinkercad, what level of knowledge should I assume they know going into my course?
I can take it if you
Yeah.
want to. So I'm going to start with Inventor first. With Inventor, I would say that somebody coming from Tinkercad, depending on how much they did on Tinkercad, but let's say that they went through a certification, right? So and maybe somebody next year goes into an inventor class and they bring the certification from Tinkercad. What you can expect them to understand is first of all, understand a 3D environment, right? Understand navigation on 3D, understand shapes, understand an extrusion, right? Because we have a sketch tool, so you can extrude. You can expect to understand the basic operations for booleans, right? Because we don't call them booleans, we call them groups, but basically you are adding or subtracting material from each other, right? So, and you will call it combine in Inventor, for example, right? So if somebody has already also been using, let's say, connectors on SimLab, then at that point it's a nice kind of segue into iMates. And since you mentioned Inventor, I am expecting you know Inventor well, so I'm saying stuff that you'll definitely get, right? So that'll be it. I would say that you can cover probably kind of the first couple hours of Animator training, in which you're also trying to make them understand navigation and sketching and stuff like that. Tinker has sketching now too, so it's not the same, but it's non-constrained. But at least, you know, again, it helps kind of get you started on all that. Regarding AutoCAD, it depends, because if you're talking about AutoCAD 3D, again, same things. And movement, navigation, sketching plus extrusions, or maybe rotations or revolves and things like that. If it's 2D, there's really not much there beyond the fact that maybe they did some sketching and they know how to make a line or a curve or something like that. But anything that goes into the 3D world, I would say you got a foundation there, right? You're probably saving yourself from the first couple hours of training, in which you invariably needs to make people kind of comfortable with the 3D environment and navigation and basic operations and things like that. I hope that was clear.
It made sense to me, and I'm not very talented with any of this stuff, so I think it was clear. Thank you, Guillermo, very much. We appreciate your time. I know you are traveling abroad while you do this. We wish you safe travels. Thank you so much for taking time out of your busy schedule to join us. Thank you, Sabrina, for being here to go over the product and address any questions we might have. And thank you to all the attendees that came. Just as one quick reminder, we will be sending out a email with the recording of the webinar, and we can make the presentation slides available. And any of you that did attend live, we are going to offer a free voucher. That voucher will be available after the exam goes live, so you will get another follow-up email towards the end of June. Thank you so much for joining us, and I hope you all have a wonderful day.
Thank you. Bye.
Thank you.